Good day, guys. How are you doing today? Today we continue our lecture series from where we stopped. Today we are looking at templates, generic programming in C++. Let's look at our slides. Why do we need template? What is templates? Templates are cornerstone of generic programming in C++. Enable us to write a single piece of code for all functions that are all classes that can operate on wide varieties of data types. So what would that definition means? That means instead of us having for example, in our simple calculator, we want to have an operation for addition, subtraction, division, multiplication of different types. Now in that situation, consider a floating point variables. That means you have to create a function for floating point variables. You also need to create another function for addition. For integer, we have separate function for addition, separate function for multiplication for integer, separate function, but you can have one functions that can able to solve all these problems. That is where generic come into place. Yeah, let's see also help us in code reusability. So write a function or class once and use it for integer, string, custom updates. Type safety. The compiler enforces type correctness at compile time, preventing many common runtime errors. Efficiency, in terms of efficiency, templates are resolved at compile time, leading to optimized code with no runtime overhead. Let's see. Templates instantiation. The process of generating type-specific code from a template is known as instantiation and occurs during compilation. This occurs during compilations. Let's see, for example, we have what you can have function generic, we have a function template, also have class templates. In function templates, we have function templates allow you to define a single function like blueprint that works for multiple data types, eliminating the need for extensive function overloading. Let's look for instance, let's find the maximum of a number out of A or B. Then if A is greater, then A return A. Or else if B is greater, return B. Otherwise, you will use a ternary operator here. This is a function. This is the open brace. This is the closed brace. This is the condition that checks if A is greater than B. Condition, this ternary operation. If this A is greater than B, return A. Otherwise, if this B is greater, return B as greater. Also the same thing, find maximum of double. If A is greater than, this cannot solve for integer values, can solve for variable, or it will only truncate those numbers. Then this is for integer, this is for floating point variables. Now, let's look at how template structures and syntactic structure look like, how it can solve that problem. We have a template on top of that functions or class. I'll give this the type name. You give it the name of the type that we want. So if we name this variable, the name of the variable, you remember this is our type, this is our function, this is the function declaration now. This is the function declaration. From this place, this is capital T. T is taking a custom type now. Maximum to check the maximum of two numbers, either double, variable, or it will just work perfectly. So this function can solve the problems of these two functions we created here. So now we check this one. We just later on, I don't want to implement it. We just call it instantiate at the point of instantiation. We just call it. We declare as return as integer. Oh, instantiate for what? Integer numbers. Can you see string? Which also is greater, using strings of what calculated them, the ASCII code characters as well. Can you see? You can use it for different types. So let's see a sample of real world scenario. Imagine an e-commerce platform where you need a utility to log changes or swap code details. A generic log and swap function can handle different types of data, e.g. product ID, price, or status flags. Generic log and swap function now. Let's create it here. We have what? We give it a name, this type name of T here. void log and swap functions take what? A type A or B constant, and take a reference of string, the field name. Then we have template T. Also applying. Remember, any point, any function that anything you want to do now, we're inserting these functions. This type, if it is int, will supply here. Int will be the same thing here. Int, if it is string, it will be strings all through. Then we can easily swap. We create a temporary variable and assign the value here. Then we can now swap the values. You can swap the value. Then let's see the application again. Let's see here, for instance, let's see the evaluation here now. Price A, price B. This, let's log swap now. Price A, price B. Then it return return this. Then we check this now. In stocks, in stock, order in stock, discontinued, log swap status, status Y, poor status. Then you can see that you can use it for different things. We use it for string here. We use for it's a product here, same thing. So that is how generic can help us to solve some problems in C++. That's why generic in Java programming languages, have generic in C# programming languages. So they enable us to have to write less code and to solve problems efficiently. Let's see class template as well. Class templates are used to create generic class, most notably for containers or data structures that can work with any data type. Let's see our traditional approach. We have class, int pair. We have public, first and second. We have int that what? We declare what? Take two with the variable here. And that one is what? Double pair. Then we have double, first, second. The same way also, we can also create a class called templates of template type 1 and type 2. It is type 1, it is type 2. So we give it the type of this and the type of the other one. We can use the same class for either int pair or double pair. So we now have our initializer list here. Our list initializer here to assign the value to this value of f and to the value of s here. If you are following us in the series, you know how list initializer works. So we can now call it for int pair and double pair. We also have strings, we have double pair, apple. Then let's see the real scenario of this. In a business application, we often need to manage different types of data, e.g. product, customers, orders. A generic repository class can handle the storage and retrieval for any data entity, avoiding code duplication. All what we are just trying to do here is to reduce time, reduce code duplications, and make the code look efficient and run efficiently. Let's see an example here. We have struct of products, also have struct of customer. We have the products take the name and the price. The customer also take the ID and the string name. So then we have our preprocessor, we have our header files, the header file vectors, and we now have our template T. We now create a class called repository of private of vector T. Which in our previous lectures we said vector are dynamic container. Array list is a dynamic arrays that can change, can pop and add, determine the amount of size we want. Then we have our type here. Based on our type here, is of supplying to it. We also push to the array, push back. This is how you add items to the array, and also have a function T return of the same type. Of the same type T. If it is int, it's going to be int. If it is string, it's going to be string. Get int return items of index. What is in the index here will be one of the same type if you look at it very well. That's T that's inside as is push into the item. So we are returning one at the index at the index. Then that is index 8 here, because index, the reason why we are having int here is that index is index and integer. So it start from 0, 1, 2, 3 to the number of items you have in your array or in your vectors list. Then we see the application here. Repository products. We also create a what? Product repo. Yeah. Product repo.add. There's 1,200. We're going to have an exercise on this question to have it more understand. So we have repository as a customer. Repository customer, take customer object, struct object, and then we pass it there. We pass customer 001 Jodo as what? John Doe as the name of the customer. So that is how we have what we can create function templating and class templating in C++. To achieve what we call generic. There's generic in Rust as well. There's generic in Java. There's generic more of the OOP programming languages. So the benefit of generic programming: code, it enables for code reusable. You can use it for different things that does changes in types. Also, enhanced type say, shift error detection from runtime to compile time. Trying to use incorrect type with a generic class or function result in a what? In a compilation error. So compilation, it is good to use a compilation error, proceed at compile time than at the runtime. So improve performance. Then also improve our performance, also higher abstraction and readability as well. So that is decouple and flexible design. Algorithm that decouple from the data they operate on, leading to more flexible and maintainable systems from our standard library, SCL, algorithms working on any container. So a type of the container is, we have the array, we also have vectors, so we also have some dictionary, a mapping, so there's a different kind of container. So we have it also in Python, in Java, other programming languages. Okay, thank you very much. Please like, share, subscribe. I'm going to see a sample or exercise on these questions as we follow. Thank you very much. Bye-bye.